Today we're going to talk about exponential and logarithmic equations. So as you can see here, any equation that contains the form b to the cx, like this one, where the exponent includes a variable, is an exponential equation. So it's about the variable being in the exponent. That's what makes it an exponential equation. There's a couple of different ways you can solve these, and depending on what you're given is going to be, what the best method will be. So let's look here. What is the solution of 16 to the 3x equals 8? Well, you might be able to notice that 16 and 8 can both be changed into the same base with different exponents. And it's usually easier to just make the base as small as you can. So 8 is 2 to the third. And 16 is 2 to the fourth. But that's still to the 3x. And you can multiply the powers, because that's a power rule. And we get 12 to the 2x equals 2 to the third. And if you have the same base with different exponents, you could just set the exponents equal to each other. We get x is 1/4. Okay, I want you to come down to this next one and I want you to try it. I'll wait. So we can change 27 into 3 to the third, and that's still to the 3x power. We can change 81 into 3 to the fourth. Now on the left, that'll be 3 to the 9x equals 3 to the 4. So 9x equals 4, so x equals 4/9. So that's the first way you can solve an exponential equation. Let's come down to a different kind. What about when the bases aren't the same or you can't make them the same? Well, that's why we learn logarithms. Because if you need to get an exponent out of the exponent, logs are the way to do it. Okay, let me show you how that works. So we have 15 to the 3x equals 285. So the first thing I'm going to do is I'm actually going to rewrite it down here because I'm going to need a little more space. So you got to think to yourself, I want the x. The x is in the exponent. How do I get him out of there? A log. That's the whole purpose of logs. Logs get exponents and take them out. So if I take the log of both sides, just like I could divide both sides or multiply both sides, I can take the log of both sides. Now, if I do that, what happens to the exponent? That's what we learned last time, that the exponent comes out front. So now we have 3x times log of 15. And we'll just leave this log 285 for now. Now remember, what are we trying to do? We're trying to solve for x. So I could do two things here. I could divide by log 15. Log 15 is just a number. It's just an annoying number, so we're not going to actually calculate it yet. And then we would get 3x equals, whatever this is. I'm just going to rewrite it there. And then we could divide by 3. So x would equal whatever that number is. Another way you could do it is, let's come over here. I'm just going to rewrite this step here. Now the 3 and the x and the log 15, those are all being multiplied by each other. And it doesn't matter what order you multiply in. So I could change this into x times 3 log of 15 equals log 285. And then I could just divide once by 3 log 15. Now, the key here in the calculator is that anytime you are multiplying or dividing with, anytime you're working with logs, first of all, when you type the log button in your calculator, it immediately gives you a parentheses. So you need to make sure that you close it. The other thing is that when you divide, a lot of people will do this. The calculator does not understand that you want these to be multiplied together first unless you tell it to. Otherwise, it will divide log 285 by 3, and then it will actually multiply it by log 15, as if the log 15 was on the top. But, that's not what you want. So you want to make sure that you put parentheses around the entire bottom, or you could use the alpha y equals button that gives you the little fraction. And then it'll be clearer, who's where. But it will automatically give you this left parenthesis, so then you have to close it with the right one. So if we type that in our calculators, and you can type it in both ways, and you'll see that 0.6953 is the answer, whether you type it in this way or if you type it in this way. Doesn't make any difference. I'm sorry, that's a 8, my fault. Okay, now it's time for you to try. You should pause the video and try this problem and then come back. Really, pause it. Okay. We have 5 to the 2x equals 130. So I'm going to start out by, I'm going to move this over a little bit, taking the log of both sides. A logarithm is an operation just like any other kind of operation, so if you can do it to one side, you can do it to the other side. So this will become 2x log 5 equals log 130. And I can divide this by 2 log 5. Log 5's cancel, the 2's cancel, and I'm left with this, which equals 1.5122. Generally, the book is asking you for 4 decimal places. And the reason why they want to be so precise is because even just a minor difference in an exponent makes a huge difference in the ultimate answer. Okay, let's talk about using our graph part of the calculator to solve. Now, we've done this a million times with other things, other kinds of functions, so I don't think you're going to have a problem here. So how can we solve this using our graphing calculator? We can type 4 to the 3x in y1. We can type 6,000 into y2, and then we find where they intersect. The problem here is going to be your window. You can see that y2 is 6,000, so that's a very high. X is in the exponent, so the x is probably not going to be very big at all. So I would say for x min and x max, you're probably fine with -10 and +10. Y min, well, y max. We have to get at least to 6,000, so I don't know, maybe 7,000. And for the y minimum, I mean, we know we have to get to 6,000, so you don't even have to put 0. You could put like 5,000. It just has to be on either side of that 6,000. So in your calculator, remember, you hit second, trace, and number 5 for intersection, and that should give us 2.0918. And remember that your answer is the x value. 2 reasons. 1, the y value is 6,000 and we already knew that. But 2, we're solving for x. We're using the y as just like a placeholder. So we actually don't really care what y equals. Okay, so I want you to try these two and get back to me. Okay, so for A, x should be 0.8588, and for B, 1.2114. So if you're not getting those, I would say try it again. You can go back in the video and listen to what I set up there again, or you can wait until the next time we have class and I can show you how to do it on the calculator as well. Okay, let's come down here with a word problem. What is a sustainable, renewable, natural resource when you manage forests properly? Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half the trees? Okay, so let's identify what we got going on here. This is a current number. So that's going to be our initial value here, or initial amount. The end question is half of the trees. So that would be half of this number. So that would be actually 600,000. So that's like your capital A. That's your final. And this is like your small a, or you can think about it as P, like the principal. This is obviously a rate of 0.07. The question is how many years. So ask yourself, what is happening to the number of trees that are in this forest? Are they going down or are they going up? Is the number of trees decreasing or increasing? This is a lumber company. They use wood. So this is a decaying exponential function. So our general, no, I keep saying that. This is general. This is specific to this problem. 1, 2, 0, 0, 0, 0, 0. Yep. Times 1 minus 0.07 to the t. That's our specific equation. And then they want us to put in 600,000 for the final amount. And they want us to solve for the t. And, you know, you can use any method at this point to go find that. I mean, you should know how to do it by hand and in your calculator. So it is important that you be able to do both. So now this is 1/2. Of course it is, because they asked us when half of the trees would be left. This is not a coincidence. And now this will be a 0.93 to the t. So I'm going to take the log of both sides. That's going to give me log of 1/2. I'm just going to write 0.5 though. Equals t times log of 0.93. So t will equal log 0.5 over log 0.93. That's going to give us 9.5513. Now, just as a reminder, the log button is next to the 7 on your calculator. And as long as you're using a common log, a log with a base 10, then you don't need to go into that math menu, which is nice. Okay, let's look at this next one. It's almost the same thing. It's still the same number of trees. How many years will it take to harvest half of the trees? But now it's just 5% instead of 7%. So the only thing that's going to change from our equation up here, I'm such a cheater, is, this is going to be, obviously that will change. This will be 0.05. So this will be 0.95. And that gives us 13.5134 years. Okay. Those are exponential equations. Let's talk about logarithmic equations. So if you use logs to solve exponential equations, then you're probably going to use exponents to solve log equations because they are inverses. So a logarithmic equation is any equation that has an x in a log function, like this one. Okay, so here are some things to try. You can try changing it right away to an exponential function. You can try condensing the logs, because you can only change it to an exponential function if you have a single log. If you've got logs all over the place, then that doesn't work. Well, we'll add to this if we see anything. So we have log 4x minus 3 equals 2. So my x is stuck inside a log function, so in order to get him out, I change it to an exponential. So the base of the log is 10 if there's nothing there. So first I'm going to change it to an exponential and just get rid of the log. So that'll be 10 to the 2 equals 4x minus 3. Now this is not a big deal at all. 100, add the 3, divide by 4, we're good. Okay? Alrighty, let's try this one. Again, it has a log of a base 10 because it doesn't say, but if it did have a log with a different base, then, that's the base you'd have to use. So we have 10 to the negative 1 equals 3 minus 2x. So 10 to the negative 1, you either want to change it to a decimal or a fraction. That's up to you. It doesn't really matter. You know what? It might be easier if we just do a decimal. So a decimal, 10 to the negative 1, will be 0.1. And then if we subtract 3, we'll get negative 2.9. And then we'll divide that by negative 2. Oops. And we get 1.45. Okay. Let's look at this example. Now, if you notice here, I have multiple logs. The only way you're going to solve a logarithmic equation if you have multiple logs is to condense it into one log, or it's just not going to work. So even though it doesn't say condense, you have to be able to recognize when to condense. You have to get this into one log. So I have x minus 3 and I have x, and there's a plus between the logs. So that means in the one single log, I'll have x minus 3 and then I'll have times x. So I can simplify that up a little bit, make it x squared minus 3x. And then change it to an exponential because I have a single logarithm. Now I hope you all recognize that this is a quadratic. So we need two numbers at times to get 10 and subtract to get 3. There we go. And then I'll get two answers, 5 and negative 2. But when you're solving a log equation, you should probably check for extraneous solutions. Which we did have to check for in other, with other powers, like when we did square root equations, and we had to check for extraneous solutions. So let's come back up to the very top, and that's always where you want to check an extraneous solution. It's the safest bet. So let's look here. If I were to put 5 up in the original problem, I'll get log of 5 minus 3 plus log of 5. All right, I mean, I don't know if that actually equals 1, but it looks legitimate. Okay. But if I put in a negative 2, you can't take the log of a negative number. It's not in a log's domain. End of story. No logs of negative numbers. You can't, it's not a thing. So you would have to cross out the extraneous. I like to circle the other one. So remember that the domain of any log, so I'm just going to put an A here, is only 0 to infinity, or x is greater than 0. You cannot have negatives here. Okay, so the negative ones are the ones, that are often not the correct answer, but you know how that works. Sometimes they're trying to trick you. So you do want to make sure that both numbers work. Both numbers could work. No numbers could work. Only one of them could work. It's just like we're solving a radical equation. Okay, let's try this one. So we have to find x, but x is stuck inside this log. There's another log nearby, so I could combine this into one log. That's not the only way I could do it, but this is one way I could do it. So 6, and I have a minus here, so that's going to mean division over 3x equals negative 2. So that's 10 to the negative 2 equals 6 over 3x. I'm going to change this into a fraction this time because this is also a fraction. And then we could cross multiply. We could get 3x equals 600. So then x equals 200. And there's no problem with that. That works. So another way we could have done it was, there's no variable in this log, is there? So as long as there's no variable in that log, you could just subtract them to the other side immediately. You could just subtract log 6. That'll leave me with negative log 3x equals negative 2 minus log 6. And then I would divide everyone by negative 1 to get rid of that, because that's annoying. And then you could say 10 to the 2 plus log 6 equals 3x. X equals 10 to the 2 plus log 6 over 3. And you should get the same answer. I'm just going to double check, though, because that's weird. So 2 plus log 6, and then 10 to that number, and then divided by 3. Yes, it's 200. So either way it works. I mean, I like this way better, but it doesn't actually matter. Okay, so that's really the end. Down at the bottom here are some practice problems. So I would recommend trying them by yourself first, and then checking, pausing the video, trying them yourself, and then you can watch if, something goes wrong. Okay. This is kind of a no-brainer. X is 2. I wouldn't even show any work for that. Okay, here I would take log of both sides. So this is the exponent. So the exponent's going to come down in front. Keep it in parentheses. Times log 2 equals log 25. Now, this one's a little trickier. What I would do now is I would divide by log 2. You could also distribute, but I don't really recommend that. So now we have y plus 1 equals log 25 over log 2. And then we'll subtract 1 from both sides. Just be careful typing it in the calculator. But you should get 3.6439. And of course, you can always type it back in. Okay. There are parentheses here, even though, like, they didn't write them. Just so you know. So I would change this into an exponential. Done. And then this one, though, I'm going to condense into 1 log. And there you go. So give the homework problems a try. There are a lot of them. Like I said for the last one, I mean, you know, if you skip around a little bit, it's not like I'm really going to notice. So although you could literally do every single one of these in your calculator, please don't, because it defeats the purpose. It's a waste of your time. And although I don't know about this year, next year you will have to do these, you know, by hand, and Mrs. Turley will be looking for you to be able to do them by hand. So I recommend you practice doing them by hand. There is one little section in the homework that says solve by using a table or something. Just ignore that. I don't care. One of the sections does say use your calculator, and I recommend that you use it for those just to practice. But the rest of them, I really want you to do them by hand. And then if you want to type in the number at the very end to get the decimal answer, that's fine. But I really don't do it until the end, because if you round too much in the middle, it makes a mess. Okay, so see you next time.